and you can check. It's gonna translate everything as we go live. So if you have issues with understanding English, please check it out. It's thanks to our sponsors. So please use this a lot. Thank you. And now, here you go.
Thank you. So yeah, today I'm going to be talking about data modeling 101. We'll see how in depth we get to go, but I'll try and start from a high level, talk about what data actually is, what a database is, what SQL is, and data-driven and more efficient. It helps with goal setting, both as an individual and as a business. It helps with validating the effectiveness of decisions, and it also helps with improving observability. So if you have visibility on how something's performing, you can kind of react to it a lot quicker. And lastly, it helps improve processes just generally. If you have information about how a process is going, you can make decisions to improve that process as you go much more quickly. So what is a database? So the way you can think of a database is just as an organized collection of data, typically stored electronically, but it doesn't have to be. So the most simple form of a database, a phone book that used to exist back in the day, that is still a database, even though it's a hard-coded database. You can also think of it as a Google Sheet or an Excel document that's got a list of rows in it, still a database. Blockchain, so Etherscan or Bitcoin blockchain, that's still a database. It's just got a collection of data stored somewhere in the ether. And then obviously the more modern types of databases, cloud warehouses like Google Cloud Platform and Snowflake. So when it comes to databases, especially ones like Google Cloud Platform and Snowflake, it becomes important to know what SQL is, because that's the way you can kind of then interact with these databases. So what is SQL? In its actual definition, it stands for structured query language, but essentially it's just a way to communicate with a database. It's a way to find and select data. It's a way to insert or update existing data or delete and create new data. There's a lot more you can do with SQL, but these are the most basic things you can do with SQL. So now that we know what SQL is, we know what data is, and we understand to some extent what a database is, we can start to think about data modeling and why it's important. So data modeling, I think this is the definition that I found to be the most intuitive. Data modeling is the process of creating an interpretation of the various data elements and their relationships to one another. All that means is that it's a way of defining how different objects connect to one another. What does one thing in one object mean for another thing in another object? In this talk, we'll focus on demonstrating the usefulness of data modeling and also discussing a specific use case and how we get started with data modeling for that use case. So the example I'm going to use for this talk is an estate agency, something that I'm sure we've all encountered, the place you go to rent, sell, buy, whatever you want to do with property, right? So before we dive any deeper, let's start with this use case. Imagine you work for an estate agency and you're starting to think about how to make the business more data-driven and less manual. What type of data do you think would be relevant here? So of course, houses for sale, houses for rent, customers. So customers both in terms of people who are looking for a property to rent or sale, or properties to list, etc. Market information about pricing, so historical price trends, market trends. Of course, website analytics, so thinking about visitors to your website, forms they might fill, like to query interest, page views, page clicks, things like that. And then, of course, location-specific data, so cafes, popular areas, parks, nature, that type of stuff. This type of data can come from many different sources, right? If you were doing this manually, you'd have to go click around different websites, click around different emails, and so on to get it. So let's think a little bit about where these types of data may come from. So it can be emails, people reaching out to you by email, saying they're interested in a property or they want to list their property. It can be research forms, people reaching out to you via your website contact form. It can be surveys, so imagine like when you think about censuses, information about people who live in certain areas, that's all done manually by someone going door to door and writing on paper. But for that to then end up in a newspaper, that someone has transformed that into a data set and put it in a database. It can also be Google, so literally just searching Google for information, that's still a source of data. And then lastly, it could be your own website or other websites. These are only some of the data sources that came to mind as I was defining this example, but there are actually so many more out there, especially when you start to think about specific types of estate agencies that might specialize in, say, like businesses versus commercial, like commercial versus individual properties. So now it'd be good to have an idea of the type of data they may care about at an estate agency. So there's just some really high level questions that they might want to answer with all these various sources. So we're thinking about how many customers are currently looking for a house. If you have everything stored in a database, that's very trivial to answer. If everything's in emails and forms, that'll be a very manual process. What is demand versus supply for housing in our managed areas? That can help them understand, where should we invest our resources? Should we be looking for more properties to add to our website? Should we be looking for more clients? Should we be advertising via Instagram or Facebook or whatever it is? What are the areas we currently have listings in? So again, they can compare it to market trends. Are we actually invested in the right areas? Do we need to expand further out? Are the houses that are listed currently priced accurately? So of course, if they have an understanding of the accuracy of their prices, they'll be able to infer, like, okay, are the properties we list actually going to sell or not? Or they can actually advise their clients better, like, is your budget realistic? Is what you're asking for realistic? And then what is the average time for listing to rented or sold? So imagine there's some type of commission process for this business. They're paying their employees based on the amount of houses they sell. If there's inefficiency in this listing to rental and sold process, that kind of process tends to fail. So this type of information is quite important. And then the last one, what percentage of properties are also listed on other platforms? So a lot of these estate agencies, they rely on exclusivity. If every property you have is on like every other website out there at different prices, you're suddenly in a lot weaker position than you would be if it was more exclusive. Yeah. So of course, as I kind of mentioned already, if you had all those data if you had all the data like stored in all these different places, stored in all these different sources, you have to go and find it manually. Like these type of questions would take literally weeks to months to answers. There are agencies out there dedicated to like going away and answering this for you, and they will charge a hell of a lot for it. But if you actually have a centralized database, a centralized place for all this data to be stored, these type of questions can be answered very quickly. There is an upfront investment, of course, but it's definitely worth the return in most cases. So let's dive a bit deeper into how we'd actually go about data modeling for this type of use case, what kind of questions we'd ask, and have a little bit of a look at some test data as well. So the first thing I think about when I'm starting a data model, so we obviously already have an idea of the use case, we have an idea of the context. The next thing to think about is what sources are actually available in the specific scenario. So here I'm going to switch to the tool we're going to use today for this talk, Snowflake. So Snowflake is just one example of a data warehouse. So in this talk, I'm going to focus mainly on the data modeling and querying aspects of it. There's a bunch of other stuff you can do in data warehouses, like you can set up like machine learning models, you can set up third-party data sources and so on. There's a lot you can do. But in this talk, I'll focus mainly on the act of loading data, querying the data, and things like that. Yep. So I'm going to touch on this bit specifically because I know in the context of the hackathon, you're probably going to be wanting to set things up from scratch. You might want to use this to make it a bit easier. So one quite nice thing about Snowflake is that even if you haven't got like, very complicated sources set up, you can still just set up a free trial account and then you kind of just click create, and then you can literally load from a file, so from a CSV file. And that's what I did to set up these test tables. So just to explore the objects we have for this talk. So we have this raw source database, which just contains the most simple tables that we're going to use. So we have the appointments table, which is literally one row per appointment, whether it's a viewing or a evaluation. We have raw clients, so that's both clients who are trying to list properties and clients who are trying to look for properties too. We have employees, and that's just the employees of the companies, whether they're an agent or a manager. We have listings, so listings that are on the website, whether they're live or inactive or so on. Properties, so again, just a list of the properties they have access to. And then transactions, and that contains any kind of transaction where property is sold, a property is delisted, a property is bought, rented rather. So I'm going to just show you back here. A little bit text heavy, but we'll talk through it a little bit slowly. So as I kind of mentioned, the employee table, this is where we store all information about employees, such as who booked appointments, who managed listings, and who closed sales and rentals. Then we start thinking about measuring conversion rates and measuring an agent success rate. That's where you can kind of find that information about which employee actually did that specific action. Then we have clients, which stores information about the clients, customers who scheduled appointments, listed properties or rent properties. List of properties, so stores information about the properties listed for sale and rent, appointments, listings, and transactions. I kind of explained this already. I won't go over it again. Another thing that's really important to note, once you're doing this part of understanding the sources you have, is to really pay attention to what is the granularity of these tables, what is the uniqueness of this table. When you want to start looking at objects together, if you don't have the understanding of like what is this in one table and how does it relate to this thing in the other table, you'll find yourself creating incorrect metrics or creating incorrect like bad data. So as I mentioned before, appointments, one row per appointment ID. And as you can see in here, you have keys. You have employee ID, client ID, and property ID. And each of these, because this is a very nice data set, point exactly to the source you can connect them to. And you can trust that will be a one-to-one join. So an employee ID in this table or client ID in this table would be an ID in the relevant client and employee tables. So now that we have a bit of an understanding of the sources that are available to us, we can start to think about how the sources relate to one another. And this tends to be the more specific part of data modeling. So this is kind of written out in a very simple form. I'm going to talk it through first as well. So when you think about the employees table, each employee can have multiple appointments, right? So the joins between an employee table and an appointments table would be one row to many rows. Then an employee can also manage multiple listings. A client can have multiple appointments. A property can have multiple appointments. A property can only have one listing. Like if it's listed once, it's not going to be listed again, else that would probably be a flaw in the data model or a flaw in the data source. But of course, the listing can change. It can change from listed to sold, delisted. It could change from a property for sale or property to rent, but it'll still only be one listing. A listing can have multiple transactions. So whether it's gone from rented to sold or back and forth. And then of course, an employee can handle multiple transactions, multiple sales, multiple rentals. So in its simplest form, you can think of it like this. An employee has many appointments and listings. A client has many appointments. Properties can have many appointments, but only one listing and one or more transactions. A listing is tied to one property and one employee, and a transaction is tied to one property and one employee. This step is really important because when you go to start answering the questions like, what is this, how many properties has this employee sold? You need to understand how the employees table can then be connected eventually to transactions table, yeah, which will be through many of these stop points. So once you have an understanding of the sources, you have an understanding of how the sources relate, you can then start to actually write the queries to define our metrics. So I'm going to use like quite a simple example. I'm hoping it's a simple example. If you have any questions, please just raise your hands, or if you want to have any comments, just raise your hands. But we'll start with a simple question of like, what is the number of appointments booked, split by type and agent? And as we go through this question, I'll just point out the elements that I'll start to think about when I'm data modeling and the things that I would note down to come back to later on. Yeah. So if we're thinking about the number of appointments booked, split by type and agent, straight away when I read this metric, I think about, okay, what tables do I need? You need the appointments table. That's your source of truth for appointments booked. You also need the employees table. That's where you know like who the employee actually is. So I've written a simple query for now, where basically I just select the employee ID from raw appointments. And then here I say, okay, when the appointment type is viewing, then count. When the appointment type is valuation, then count to get those two separate metrics. So now I have a list of all employee IDs, viewing appointments, and valuation appointments. Of course, this is great, it answers the questions, but this won't mean anything to a manager or mean anything to the business. They have no idea who these employees are. That's when it becomes important. Okay, so how do I get that information about who these employees actually are? So what we can do now is start to think about the relationships we spoke about before, right? So we know that every appointment has an employee ID assigned to it, and we know the employee ID is a one-to-one relationship with the raw employees table. So here we can then join in raw employees, and then in SQL, this is one of the important things, like defining that join key, if you're not familiar with SQL. So here we can say join on employment, raw appointments dot employee ID, employees dot employee ID. And then here, we can then include the employee. Let's just do first name for simplicity for now. And then here, I'll just also define where this comes from. Okay, and suddenly you have something that's a bit more useful to your managers. So when I try to explain data modeling and why it's important, it's things like this. Like if you're running this query every single week, or suddenly you want to add in more information every week, it's kind of quite unuseful, not useful, and quite inefficient to keep running these joins over and over again. Whenever you report an employee, you want to know the first name. So it would make sense to define that object that contains the data you care about along with the employee's name. Yes, that's the kind of thing I would, while I'm doing this process of defining these queries and defining these metrics, I'm noting that, okay, cool, it's going to be useful to have this table that has these things in one place and not run it every single time. Yeah. The next thing that they might want to ask once they see that is that, okay, what is their no-show rate? So an appointment can be successful or it can be not successful. So if we just look at the appointments table, so 10 rows, it's kind of easy to look at. But we can see that an appointment can be completed, someone cannot show up, scheduled, even cancelled. So if the manager wants to know, okay, what's their no-show rate? Or maybe even better question, what's the success rate? What's the completed rate of the viewings? So if we wanted to create that type of metric, we essentially want to know, okay, what's the total number of appointments? What's the total number of completed appointments? And then obviously make a percentage out of it, right? So I'm going to do this live and hopefully I don't make a mistake, but essentially, I'm also a serial copy and paster, so bear with me. Essentially, we want to count the distinct situations where the status is completed. I'm just going to double check the format. Okay, so that will give us the number of successful appointments that went to completion state. And then we'll divide by, and we'll do the exact same thing. In fact, no, we'll just divide by the total number of appointments. Yeah. And that if null is just like, if for some reason there's like zero, not if null, sorry, null if. If for some reason there's a zero, it doesn't throw an error. Sorry?
Where do you get a divide by zero?
Yeah, no, so I put the null if. So if this value equals zero, then it will turn to null and then your percentage rate will be null.
Oh, I'm sorry. I got that.
Yeah, no worries, yeah. Probably even better, you probably do a class with like 1 or 0, like decide what does it mean if they've had no appointments? Is it a success or not a success? But yeah, in the simplest rate, then at least at a high level, you can see, okay, which employee is the most successful? I mean, Bob, but it's just 2 viewing appointments, pretty good. And then this employee had 1 appointment, but no one turned up for it. Interesting things I'd observe here. Actually, no, never mind. Sorry. But yeah, so that's a very simple query about how you might be able to calculate success rate. Again, as I'm working through this, I'll start to think about, so you get a question coming from someone or coming from the use case you're trying to work with, you start working through it. As you start to explore the data, you get a lot more familiar with what the data can tell you. So I've written the success rate, the idea of how successful are these viewing appointments. But what might be more useful is to take it a little bit further and think, okay, what does it actually mean for success for this business? Is it viewing appointments coming through, or is the property being rented or sold? And then once you get those questions, you see how the query will grow quite quickly, right? Because suddenly then you're joining in, okay, a property being listed, yes or no? A property coming through as a seller rental, yes or no? And suddenly you've got like 4 tables being joined in, right? So yeah, all that to say, I'm not going to do it live because it is a process. All that to say, that's kind of where data modeling really, really excels, is when you have those kind of situations and questions that require so many more layers. The next question I kind of want to touch on a little bit is, what is the current status of all properties on our platform, right? It's a question that definitely is important to know. Like, you don't want to book a viewing if the property is not actually available. You don't want to take on more properties if you actually have too much of a portfolio ready to you. You don't want to assign an agent to something if all the properties are like in the viewing stage. Do you know what I mean? So what is the current status of all the properties on our platform? I was going to be cruel and see if anyone wants to volunteer to try and write this query. Anyone feel, no? Okay, I'll do it. No, go ahead. If you're like...
What was the question again?
So the question is, what is the current status of all properties on our platform?
All properties.
Mhm.
So just getting the status.
Exactly. So we've currently got the properties table. A property can be listed. A property can be sold or rented. So there's 3 tables we want to consider here.
And listed, you said?
Yeah.
Okay.
Yeah.
Yeah, why not?
Cool. No worries.
Oh no, now it's been so long. I'm like, wait, when was the last time I wrote a query?
I'm going to talk a little bit as you do, if that's okay.
Sure.
So one thing you'll notice with people who are really familiar with SQL is they tend to start with writing the from and the joins of the tables. And that's because of the same steps we just spoke through, right? The importance of understanding how your tables relate to each other. Like, as long as you know the metrics you need, where they're coming from, the most difficult part is, okay, cool, how do I combine these sources to be able to write this query and trust the answer will be correct? So here he started with the properties table. That's a source of truth for properties we have on our portfolio. And then he's joined in listings so we can understand, is this property listed or not? And now he's going to join in.
We just want do we just want only listings or do we want by status?
Status, so
Status, okay.
transactions, yeah.
Cool, thank you.
And then we're joining transactions, so that's what tells us, like, is the property sold, rented, or anything else that might be available.
Oh, no. Typing is hard. Oops. Oops, oops, oops. I'm so sorry, I'm not typing well today.
So, earlier, we also saw how all the tables relate to each other. So we saw that properties, the unique key, the primary key is a property ID. So we're using that in all the joins. So making sure that as we join these tables in, we're not fanning out the data, we're not creating bad data or false rows, false rows.
Oh man, okay. I'm not 100% familiar with this specific flavor, so please correct me if my syntax is wrong.
Yeah, no worries. Case and space web.
Okay, space one, okay. And then paren or no? No
No.
paren? Okay. So. Am I on the right track here?
I'll make some edits after, but it's
Okay.
just fine, yeah.
Okay. Oh, also this is wrong. Listings ID, correct?
Yeah, when it's not null, then it's listed. Or when it's null, then it's not listed.
Oh, right, thank you. Oh, wrong button. Thank you, thank you.
Yeah.
Cool. And this is transactions ID, and I have a typo. Oh, I'm sorry, I forgot that it was Mac. And what is this, bought, I guess, or sold, or
Yeah, it's just sold.
sold?
Yeah.
And then else would be what,
Else,
unknown?
let's do
Null?
unknown for now. Yeah,
Unknown.
and I'll go through the process of like,
Cool.
how can we
All right,
fill
I'll
these
get out of
gaps.
your way then. Is that good?
No worries. Yeah, that's good. Thank you. Okay, so I'm going to make some quick edits to this. So we want to know the current status of all properties on our platform. So of course, property ID. So of course, you should not add in like an identifier for the property. So in this case, we'll add in, I'm also wary of time, so I'll just try and keep this quick. Okay, just going to run this for now as it is. I think non-pure.
Sorry.
No worries.
Oh,
Ah.
and listings will.
Listings. So sorry. No worries. Okay, nice. So can anyone spot an issue here or anything that comes into mind when you think intuitively about how the estate agency process works? So one thing to note about case whens is that it's sequential. It'll go through the first condition. If it's true, it won't look at the rest of them. We'll just move on. So if we think about the process for listing a property, oh, did you have your hand up? Oh, no, sorry. If you think about the process for listing a property, right? If something is sold, of course, it was once listed. So you need to make sure the waterfall order you have is from the least likely thing to happen down to the most likely thing to happen. Yeah. So in this case, we want to start with, okay, is the property currently at status sold? If it's not sold, has it been listed? If it's not been listed, etc., etc., etc. Because of time, I'm not going to spend too much time going through all the other conditions, but what you can start to do is look at your data. So look at the raw transactions table. What are the possibilities for transaction type? Look at the listings table. What are the possibilities for is live? So you can see, for example, this listing ID is not null condition. You might want to change that condition a little bit to look at that is live column and so on. So all that to say, when it comes to data modeling, the most important thing is like really spending the time to understand your data. Like whenever I do client projects, the bulk of the project is spent on understanding the data sources, where it falls, what questions they want to answer, what does the business actually do, how does it work, and so on. That's like the most important factor here. So step 4, which we won't cover today, but that's when at this point you have a good understanding of the data, you've written some queries, you've validated your metrics, you have a good understanding of what you're playing with. That's where you can start to design your core data models. And this is where tools like dbt will be quite useful. So dbt is a tool for essentially, instead of you having like a bunch of queries saved in like worksheets in Snowflake, you could then connect this to dbt and just have like the query stored in a file, and then it will like run it on an automated basis or a recurring basis. But this is like the best starting point, and then obviously build from there. I won't go into dbt now because we've run out of time, but if you have any questions, just come talk to me and I can answer anything or point you in the right directions. Both Snowflake and dbt offer free trials, so even if you want to use it today, you can play around a bit and it doesn't cost you anything. I think it's about 30 days for both. So at a high level, today we've covered what data is and why it's important. We've also touched on an intro to data modeling with using this estate agency as an example and types of things you might think about or places you might kind of jump into or drop into when you're doing this process, and then briefly mention dbt. So yeah, any questions or anything from anyone? No? Okay, cool. Then thank you for listening. I hope it was useful.